In this lecture, we will briefly discuss material properties and then move on to Gouraud shading, which is a per vertex shading model. Material properties should match the terms in the light source model. Hence, material properties are specified by the ambient, diffuse, and specular reflectivity coefficients Ka, Kd, and Ks. The A value gives opacity. Here is an example where we have defined the ambient property as a white light source with giving 0.2 to the red, green, and blue components. However, the diffuse property is defined as 0.8, 0.8, which is yellowish kind of light, whereas the specular component is defined again with 111 values, which is white light, and giving it a shininess coefficient of 100. So this is a yellow, not fully saturated object. It is smooth and shiny because of the shininess value of 100. Now, since the material properties are specified as RGBA, the first three components stand for color. The last one is for opacity or translucency of the surface. If we set this value less than 1, that will mean that some light passes through the surface. The default value is always opaque if we do not specify the value of A. There are three methods for shading a polygon. The first method is flat shading. The next two methods are both smooth shading methods. One of them is called Gouraud shading, the other one the Phong shading. Note that both Gouraud shading and Phong shading are smooth shading techniques. The differences will be clear in the next slides. Now recall that OpenGL handles only triangles, so that the term polygon and polygonal mesh is synonymous with triangle and triangular mesh. So let's talk about flat shading first. Recall that to compute the shading value at a point, we need to know the light vector L, the normal vector N, and the view vector V. So for a given polygon, it will have its normal vector. So as we move from one point to the next point inside the polygon, the I and V should vary. So, the L, which is the light vector, and the V vector, both of these would vary. In the flat shading model, they are assumed to be constant. A single shading calculation is performed for each polygon hence. The entire polygon will thus get a single shading value. This technique is thus known as the flat or the constant shading technique. So the advantages of flat shading is that this is a computationally cheap method. We only need to do the calculation once for a polygon. However, the disadvantage is that the boundary edges of the polygons are very obvious, and when they are rendered, they will show differences in shading when you go from one polygon to the other. This shading method is suitable when the viewer or the light source are far away from the polygon. Here is an example of a flat shaded polygonal mesh. We can see that all the edges are quite obvious. We can actually draw on top of these edges. And because these two polygons have exactly the same model, we cannot differentiate between the edge here, but all these edges are quite obvious. In OpenGL, we specify flat shading as follows. We say GL shade model and then use GL_flat. In the Gouraud shading method, which is one type of smooth shading technique, the normal vector at each vertex of the polygon is first computed. So rather than using the polygon normal, we need the vertex normals. The shading value at each vertex is then computed using the light vector L, the normal vector N of the vertex, and the view vector V. Shading values of interior points of the polygon are obtained by interpolating the shading values at the vertices. For example, if we want to find out the shading value of this, we would interpolate the shading value from this point, and from this point. So it is going to be a linear combination of all these three shading values, not the normal, the shading values. And the weights will depend upon how far this point is from each of these vertices. So if we come closer to this vertex, we will get the shade of this vertex more compared to the ones that are far. So these are far, these two vertices are far, they will not affect the shade at this point as much as this point affects it. As one shading calculation is required for each vertex, it is also known as the per vertex shading. So Gouraud shading is also called per vertex shading. And Gouraud shading is just one type of smooth shading. There is another type as well. The main advantage of Gouraud shading is that compared to flat shading, this gives smoother rendering results. However, the disadvantage is that it is computationally more intensive compared to flat shading. So flat shading is the fastest, and this is slower than flat shading. This is the default implementation in OpenGL. So if you do not specify any shading method, OpenGL will use smooth shading, which is Gouraud shading. So you can also specify this method explicitly by using gl_smooth, which would be Gouraud shading.